first website I found that conveniently summarized many arguments that I repeatedly found during my research was this site. I will admit I don't love the condescending presentation on this page, but it does have well-developed arguments. Not to mention, I have seen the same holier-than-thou attitude displayed by climate believers. I will also say that this was written a while ago, but again, it summed up a lot of arguments that I still see, and it's a good reference for some of the better contrarian arguments. I also found this website that contains a lot of the same ones as well as counterpoints to them. However, these counterpoints do not go in depth, so I'm using them more as a tool to summarize. So keeping all of this in mind, let's just dive in. I'm going to try and go from the simplest and less significant arguments to the most significant ones. This is one I've seen floating around a few websites. Supposedly, the scientific consensus on global warming is inaccurate due to this petition that clearly shows 30,000 scientists agreeing that there is no convincing scientific evidence that human release of carbon dioxide, methane, or other greenhouse gases is causing or will in the foreseeable future cause catastrophic heating of the Earth's atmosphere and disruption of the Earth's climate. That's it, isn't it? If there's no actual consensus, then a lot of validity in the left's arguments goes away, right? Well, I'm going over this argument first because it's pretty easy to disprove for a number of reasons. For one, this petition started over 20 years ago, and it was last updated in 2007. This isn't an enormous problem, but considering the original proposal was to reject the Kyoto Protocol, an international treaty to reduce carbon emissions, I'd say its premise is a little out of date. Secondly, there are issues with vaguely claiming signatures by 30,000 scientists disprove the global warming consensus. While I do trust the organizers of this project do weed out fake names and double signatures, I do not trust the validity of 30,000 scientists. If it were 30,000 scientists with some sort of background in climate or atmospheric sciences, I would be more convinced by this. I would even be more thoroughly convinced if most of the scientists had some sort of earth science or oceanography background. Additionally, I do think it's important to note that many scientists do rely on people outside of their fields to provide research for aspects of their careers that overlap. Even with the mere possibility all of these scientists do climate-related research, when you look at the credentials of the signers, the petition becomes much more questionable. What does medicine have to do with climate science? And then there's the vague general engineering and general science category, which involves the study of metals. What does computer science have to do with all this, other than perhaps making climate models? I think it's extremely doubtful all of the scientists here are working on climate-related studies when their backgrounds aren't even in climate science. I wasn't the only person to notice this. This article states that only 0.1% of the signers were climate scientists, and even adding those with atmospheric science backgrounds only adds 0.4% for a total of 0.5% of signers who do climate or atmospheric studies. This article also explains some shaky beginnings of the Petition Project, such as one of the institutes being backed by Exxon and scientists being lured into signing it with faulty evidence. I cannot confirm for certain that these things happened, but I would not at all be surprised if the credentials of this petition were manipulated and backed by people supporting carbon-based industries. Another problem that this article points out, and that I also notice, is that on top of some of the careers being irrelevant to climate science, it's difficult to verify if any of the signatures are real. Searching the names of signers online often results in mixed or simply no results. Granted, some of the scientists may not have an online presence, or they value their privacy. It's also possible that some of them have common names that are buried in the 7th page of Google. At the same time, though, there aren't many standout names within the list of signatures. The last issue I want to mention is the signature process. This petition is primarily circulated by U.S. Postal Service mailing to scientists. Included in the mailing are the petition card, the letter from Frederick Seitz, the review article, and a return envelope. If a scientist wishes to sign, he fills out the petition and mails it to the project by first-class mail. At first, it may seem like this lends more validity because it's not random people signing online. Well, for one, there is an option to sign online now that could be potentially faulty, but really? The creators just send this to people and see if they get a signature back? How do they choose the scientists? Is it anyone goes as long as they studied something science-related in school? Is it based off of studies done by the individuals? I have no doubt that there were criteria for this petition, but I don't know what those are other than science. There's no way this petition was just sent out to random people, but it may as well have been considering there's no information about it. And this seems kind of weird to me. I should mention this petition was not started by some rando. It was started by Frederick Seitz, a renowned physicist, previous president of the National Academy of Sciences and president of Rockefeller University. He also received the National Medal of Science from Richard Nixon in 1973. He specialized in researching properties of matter and contributed a lot to quantum theory. Despite all of this, he still held denialist views on global warming. Supposedly, his peers did not agree with him on this standpoint, and one of his friends, Dr. Press, President Jimmy Carter's scientific advisor, said Seitz was not a specialist in this field. My grander point here is that just because someone is a well-respected scientist doesn't necessarily mean that they're an expert in everything, and it also doesn't mean their beliefs about a topic should be held in higher regard than those actually doing the research. I believe I've made my case for the skeptic argument being invalid. It's pretty much as this website says. Recent studies have shown that about 97% of active climate researchers agree that climate change is human-caused. In truth, the signatories of the petition largely had training irrelevant to climate science such as veterinary medicine or no scientific expertise at all. Not to mention, there is hypocrisy in going against the scientific consensus of climate change with a petition, which is practically just a way to create a different mini-consensus to use as ammo. There are valid reasons to be against consensus science. As this site puts it, an important consideration in this discussion is that we are attempting to define a single number to represent a range of opinions which have many nuances. Fighting the 97% of scientists agree with global warming with a, oh no, 30,000 scientists don't agree with global warming is absurd to me. This petition has the validity of a Change.org petition, and I think this argument should be dropped by anyone skeptical of climate change. Simply put, there are better, more interesting arguments skeptical of climate change. Last March, global warming fanatic Al Gore used a picture of two polar bears purportedly stranded on melting ice off the coast of Alaska as a visual aid to support his claim that man-made global warming is doing great harm to Mother Earth. The one he chose, but didn't offer to pay for right away, turned out to be a photo of a polar bear and her cub out doing what healthy, happy polar bears do on a wave-eroded chunk of ice not all that far from shore in the Beaumont Sea north of Barstow, Alaska. It's a hoax, folks. The bears, which can swim distances of 100 miles or more, weren't stranded. They were merely taking a break and watching the boat go by when a lady snapped their picture. So, are polar bears dying? Are glaciers melting? Frankly, I think the misuse of this picture is indisputable, especially since it was sloppily credited to the wrong person upon first usage. It's unfortunate that this image was used in politics rather than in education, although it's almost inevitable at this point. Polar bears are important, but definitely not the weak, helpless creatures we perceive them to be. And as the authors point out, polar bears are happy to attack and eat any convenient humans, and they are actually quite scary in the sense that they recognize humans as prey. Then again, just because they can kill us doesn't mean we shouldn't care about them for environmental purposes. So, before we can even deduce how polar bears are doing, we should look into glaciers, considering ice and ice melt are a large part of polar bear behavior. Are glaciers actually melting? Supposedly not, according to some people. We found 50 glaciers are advancing in New Zealand, others growing in Alaska, Switzerland, the Himalayas, and even our old friend, Mount St. Helens, is sprouting a brand new crater glacier that is advancing at 3 feet per year. Antarctic ice is growing, and Arctic sea ice is recovering. Is this massive melting we're hearing about in the news even happening? Let's find out. In the United States, Glacier National Park is experiencing large-scale glacial loss. In 1966, 35 active, named glaciers were in the park. As of now, 9 of these are no longer considered active, and the other 26 are still experiencing reductions. This page also showcases images of glacier reduction over the years. Now, I already need to point out my first issue on both sides of the glacier argument. While I'm in no doubt that Glacier National Park is experiencing reduction, the extent shown in these images may or may not be misleading. Historically and today, photographing the glaciers can only occur in a narrow window in late August and early September after the previous winter snow has melted from the ice and before the first snows of autumn. It is only in the late summer season that the glaciers can be clearly seen. However, in some of these images, it's difficult to make out the difference between snow and glacier ice. Not to mention, the precise dates of these images are not given, and if the images on the left are even taken a month earlier in the summer than the ones on the right, the difference could be enormous just because of natural seasonal melt. I should mention, though, that the skeptic page does the exact same thing when claiming the TSAA glacier is growing. Yes, this glacier most certainly could be growing, or at least might have been when the article was written, but the images are still misleading in the exact same way here. The left picture was taken in July and the right was in June. I think the only fact this proves is that glaciers change massively between seasons, and depending on when pictures are taken, real melting of glaciers can be extremely exaggerated or severely underestimated. Even though the loss in Glacier National Park has been severely overestimated in the past, overall loss of glaciers is evident not only by photography, but by satellite data and aerial imagery. Conditions for Antarctic ice sheets are a little more complicated. The past few decades have shown large variability within Antarctic sea ice, with a slight upward trend, meaning Antarctica is gaining ice. However, since September 2016, Antarctic sea ice extents have fallen well below the 1981 through 2010 average and even below the long-term range of variability for nearly every month. Extents for 2017 and 2018 were the lowest on record for both winter maximum and summer minimum. In contrast, NASA, in the recent Ice Sheet Mass Balance Intercomparison Exercise, IMBIE, found Antarctic sea ice loss had tripled since 2012, particularly in West Antarctica from warm ocean water. Prior to 2012, ice sheet loss was at a steady rate of about 83.8 billion tons, 76 billion metric tons per year. Since 2012, the amount of ice loss per year has tripled to 241.4 billion tons, 219 billion metric tons. The Antarctic Peninsula is losing ice as well. East Antarctica, on the other hand, was found to be relatively stable, gaining an average of 5.5 billion tons, 5 billion metric tons of ice per year. However, there is even some evidence to suggest that East Antarctica isn't as stable as previously believed. A study done in 2019 shows massive ice loss for two glaciers in East Antarctica, being the Totten and Moscow University glaciers. The Totten Glacier is massive, so if it is melting, that's pretty significant. It is difficult to measure fully how much either of these glaciers are melting, as Antarctica is not an easy place to access for scientists due to costs and tricky landscapes, so there isn't much close-up photography available. However, satellite data from this study shows that the Totten and Moscow University glaciers were losing about 15% more ice each year than they were gaining from snow falling on their surfaces. Overall, despite improvements in satellite gear and more studies done in Antarctica, it is unclear just how much ice sheet melting is taking place. For now, though, I think it's safe to assume that the West is more unstable than the East. The West, as well as the Antarctic Peninsula, are losing more ice than the East, and the East most likely has areas of ice gain and areas of ice loss. Another small fact to note is that glacier loss on South Georgia Island, an island with polar conditions that exist between Antarctica and South America, has had a very large, very consistent loss in glaciers. These images show two glaciers that have retreated significantly between September 2000 and September 2016. I'm showing this because other areas somewhat close to the Antarctic may predict how other areas in polar conditions will behave in the future. So just keep all of this in mind. In late July 2019, one of the biggest Greenland ice melts ever recorded took place. This was due to an unusually warm air mass from Europe reaching Greenland, which is admittedly an unusual occurrence. The melt was estimated to reach 55 billion tons, and 90% of the ice on Greenland reached melting points at the height of this heat wave. The temperature in Greenland was above freezing for 11 hours, which is a record high. Overall, Greenland loses around 280 gigatons of ice per year. This graphic shows, as of 2016, where the ice is being lost, and to what extent. Clear that the larger trend is glacial melt in Greenland. There are even some scientists arguing that Greenland will soon reach a tipping point in which ice may melt extremely rapidly from any small climate shift. Still, there are exceptions. Jakobshavn Glacier is a major glacier in Greenland that has been growing in recent years. Before 2016, the glacier was retreating, but as of 2019, it has grown and thickened. It is believed that this is being caused by an influx of cold ocean water. This cold water comes from a climate pattern called the North Atlantic Oscillation. An oscillation is a climate pattern that typically involves switches between two states in particular regions. It's basically just a climate cycle. The North Atlantic Oscillation has two potential phases, a positive phase and a negative phase. Very generally speaking, positive phases see a stronger jet stream, warm and stormy weather in northern Europe, less precipitation in southern Europe, and less stormy, cold conditions on the east coast of the United States. The opposite is basically true for a negative phase. In short, this is an occasional climate shift that can cause great changes in weather and temperatures in the Atlantic region. It is believed that fluctuations in this oscillation have caused cooler ocean temperatures, and the cooler ocean temperatures have caused the expansion in the Jakobshavn Glacier. Even if it weren't believed to be this oscillation, the temperatures of water in that area have been recorded as lower than previously. It's also important to note that scientists insist that this does not reverse the larger trend of Greenland's glaciers melting, but it does suggest the melting is slower and more complex than first thought. This is an entire other point, honestly. Pointing to a few growing glaciers in the name of healthy skepticism does not prove that glaciers are growing overall. It's ridiculous to act as if global trends are incorrect because of some outliers, and in some cases, explainable outliers. Global climate change is bound to impact different parts of the Earth in different ways, and I find it frustrating when skeptics of climate change selectively choose whether or not they want to criticize scientists for overgeneralizing, or selectively choose to apply regional trends to the entire globe. Granted, I find it just as frustrating when alarmists refuse to acknowledge the complexity of our climate and pretend as though there are already no glaciers left. The climate is complicated, and the way we think about it and research it needs to become more so too. This will be a running theme, trust me. This page also mentions growing glaciers in the Himalayas. Again, this is likely due to regional climate differences. While precipitation is increasing across the Himalayas, most of the moisture drops in the summer, except in Karakoram, where snow dominates the scene. In a study done on the Karakoram region, researchers investigated temperature and precipitation data from satellites as well as data from local meteorological stations. While precipitation increases over the entire region, Karakoram gets more precipitation in winter, which means more snow. With this information, researchers also made a model to simulate the conditions to fill in for some information holes. They used the same climate conditions to see if the model's outcome aligned with what is happening in Karakoram, and it did. Though the researchers didn't test the idea, this snow presumably feeds Karakoram's glaciers, keeping them from retreating. This isn't at all an outlandish assumption, as glaciers begin as snow in the first place. This is just one study though. Is there anything else? Well, some of these weather patterns may be due to a circulation system or a vortex over the Karakoram region. In winter, the vortex affects the temperature over the whole 2,000-kilometer mountain range, but in the summer the vortex contracts and has an effect only over the Karakoram and the western Pamir. This induces an anomalous cooling in the summer which is different to the warming seen over the rest of the Himalayas. The conditions over Karakoram have also been stormier, providing temperature control and lessening melting. We conclude that interannual variability in the Karakoram vortex, quantified by our circulation metric, explains the variability and energy-constrained ablation manifested in river flows across the Himalaya, with important implications for Himalayan glaciers' futures. So the growth of these glaciers is likely because of this vortex, as well as the precipitation and temperature patterns that result from it. So, we've seen a few instances like these where glacier growth is contained to small regions, but what if the glacier melt is also just regional? I think it would be biased to rule out precipitation, or weather changes, or ocean currents, or anything else that may be causing the melting. The authors of this page cite a volcanic hotspot as the reason for so much melting in Greenland. This idea comes from a 2000 study that found a hotspot in northeast Greenland. As of this study, the temperature of the spot was not known. Von Frase's team combined gravity measurements of the area taken by a Naval Research Laboratory aircraft with airborne radar measurements taken by research partners at the University of Kansas. The combined map revealed changes in mass beneath the Earth's crust, and the topography of the crust where it meets the ice sheet. These researchers explain that the Earth's crust may be thinner where these hotspots are, and the extreme heat from magma beneath the crust could cause warming. They also explain that while there is a potential the hotspot is a volcano, it is more than likely just uneven heat distribution under the Earth. Overall, these scientists believe that geothermal heat could have a role in some glacial melt. I think the issue here is not within the study, but how this study was used in the article. One thing that you will see a lot of in this video in regards to climate science is uncertainty, and there is a lot of that here. Still, uncertainty does not mean that geothermal energy melting glaciers isn't possible. Geothermal heat very well may play a role, but it is extremely difficult to measure at this point. It also doesn't explain the larger scale melts happening in summer months, and considering there was only one potential hotspot found, this doesn't account for the rest of Greenland. Not to mention the fact that current volcanic activity in Greenland is known to be very low. There were likely volcanoes in Greenland in the distant past, but not now. Nevertheless, hotspots can form anywhere and don't even have to be volcanic. But as far as Greenland goes, while the study shows that there are likely hotspots, we don't know how warm these hotspots are, nor if they could cause melting. And we do know that warmer air and ocean temperatures cause melting. Al Gore tells us the Greenland ice cap is thinning, but he doesn't mention that a newly discovered volcanic hotspot may be a contributor, along with warming on the coast due to warmer waters coming up from the Gulf Stream. In general, we found growing glaciers outpacing melting glaciers by a good margin. Nothing like cherry-picking an isolated example to create panic, Al. Al Gore certainly isn't the best source for climate information, but it doesn't take cherry-picking to see that glaciers, overall, are melting. Al Gore is good at cherry-picking polar bear photographs though, so considering we can now confidently deduce that glaciers are melting overall, how are the polar bears doing? The International Union for Conservation of Nature, IUCN, uses 9 categories to describe the states of species. The lowest of these is least concerned, and the highest of these is obviously extinct. The state right before endangered is vulnerable, which means a species is vulnerable to becoming endangered. Polar bears are considered vulnerable internationally. The current estimated number of polar bears is anywhere from 21,000 to 31,000. I'm going to cut to the chase right here and say, from a historical standpoint, polar bears are most likely increasing, or at least they increased for a while after 1973. This is because in 1973, the United States, Canada, Denmark, Norway, and the USSR signed the International Agreement on the Conservation of Polar Bears and Their Habitat. Other than Russia, which supposedly already had a ban on polar bear hunting, this was the first effort to conserve the polar bear population. A chart on polar bear populations gives us a lot of information, or perhaps a lot of information in the form of information deficit. Many of these areas have insufficient data, but the ones with data are mixed. Most areas have populations that are stable or likely stable, and the decreasing populations slightly outnumber the growing ones. Why are the populations measured this way anyways, in multiple groups? Well, as this site points out, polar bears are not a single large homogeneous population that roams throughout the Arctic. Instead, groups of polar bears referred to as stocks or populations are distributed throughout the Arctic. There are 19 of these subpopulations. Not only that, but polar bears are isolated creatures in general. They tend not to live in groups, other than mothers with cubs or when mating. Polar bears also don't mate frequently. Females reproduce every 4 to 8 years. Sometimes, male polar bears will kill cubs, which makes it easier for populations to decline between reproduction. Speaking of the cubs, the overall condition of the Arctic may be impacting some polar bear populations more than others. In the western Hudson Bay, researchers have noted over time that earlier ice melts result in worsened polar bear health and reproduction. This means less cubs, which obviously means less polar bears. The concern about melting ice in polar bear populations is interesting, because I've noticed that either way it's problematic. More bears, less ice? That's an issue. Less bears, less ice? Still a problem. But considering we can estimate how many there are now, is 21,000 to 31,000 not enough? As in, is this a decreased population size or a relatively normal size? Well, that's actually not an easy question to answer. This recent article writes about how polar bears are thriving. Now, listen, I'm not typically one to question an article's legitimacy solely based off of where it's published, unless it's like BuzzFeed or something. But when the author says this article was published in a French magazine called Current Values, I immediately got the impression this was some sort of French magazine version of PragerU. Yes, I'm sorry, it's a snap judgment and I'm being mean here, but I got the vibe and I'm pretty sure I'm right about this bias just from reading a few titles such as The Landing, 1 million refugees at our ports, 68% of French people are against receiving immigrants, or Anti-politically correct, the Quebecian bulldozer being assaulted by conformist thinking. I don't think this makes the article invalid, but it goes to show you how much this information can be exaggerated or misinterpreted depending on usage, especially when the title of the magazine this article is featured in is called Investigation of Green Totalitarianism, the Phonies of Ecology. They play on our fears, forbid debate, and recruit the youth. Climate alarmism may certainly be overdramatic nowadays, but wow. Anyways, big sidetrack there. The author does make a good point in saying that there is an enormous disconnect between polar bear public opinion and reality. They have been on the endangered species list before, and I have no doubt that many people still think that they're on that list. This article says that when overhunting was halted in 1973, polar bear populations doubled. The author criticizes models that predicted polar bears being near extinct in ice melt conditions that are currently happening. Out of 19 designated subpopulations worldwide, 10 subpopulations were expected to be wiped out when summer sea ice routinely fell to 42% or less of 1979 levels. However, the dramatic decline in summer sea ice came much sooner than expected. By 2007, it was already underway. Sea ice levels not expected until 2050 have existed virtually every year since then. So basically, despite sea ice melt, polar bears are not declining as projections said they would. Moreover, against all expectations, in regions where sea ice melt has been the most pronounced, in the Barents and Chukchi Seas, bears are thriving. They are abundant, in good condition, and reproducing well. Overall, this article affirms that polar bears are not declining. Meanwhile, this short article is more skeptical. Dr. Stephen C. Amstrup states that the number of polar bears collected in the 60s is not well accepted by scientists, nor does it show an accurate number to compare current numbers to. I've definitely seen the number 5,000 floating around when referring to polar bear numbers in the 70s, but I haven't tracked it to a source. I wouldn't be surprised if the original population was over 5,000, but still in a depleted state from overhunting. This author admits that population rebound most likely occurred after hunting restrictions, but overall concludes that loss of habitat is still the biggest threat to current populations. Basically, if you're not understanding the conflict here, let me simplify. Because we are unsure of exactly how many polar bears there were in the 60s and 70s, we cannot be sure how much populations are growing or shrinking currently. We don't have a super clear baseline. What are we supposed to believe? It's difficult to find the truth about polar bears. Oh wait, here it is! Okay, but in all seriousness, I think this article does a better job at summing up the polar bear question than many others I've found. Zach Unger, the author, describes Western Hudson Bay and its annual bear gathering in the fall. He also explains how data shows an increase in bears here. This article was written in 2012, and as we have now seen, bears are likely decreasing here, so some of this information may be a little out of date. However, he still makes a good point about how there are more bears than one would expect with current Arctic ice melting. He also highlights how many of the subpopulations are data deficient, so in reality, we don't know how many bears are in those areas. In quoting Lily Peacock, a wildlife biologist, the author demonstrates how spotting more bears may not be a good thing. All indications are that the future does not look bright. While population trends might appear stable, she says, we're picking up declines in body condition that are really frightening. Scientists have shown a direct correlation between warm years and skinny bears. Even more distressing, one study predicted that 40 to 73% of pregnant females could fail to deliver healthy cubs if ice breakup happens 1 month earlier than in the 1990s. It is also pointed out that with more ice breakup comes more bear visibility when counting, as in, bears blend in more on ice than on land, so more bears being visible may actually be a sign of declining species, or at the very least, not a sign of increasing species. Another thing to mention is, specifically in 1983, the European Economic Community banned the importation of hides of whitecoat harp seal pups. This law is in direct correlation with a polar bear increase in Davis Strait, so there are other non-climate related factors that could be impacting polar bears in the short term. I keep mentioning bear increases in certain areas, decreases in others, areas where they're less healthy, but why? Can it not be generalized? Well, maybe not. The health of polar bears may actually depend on location. Remember how I mentioned that there are 19 subpopulations of polar bears? As Unger points out, polar bears that make their home in the James Bay at the 53rd parallel north have experienced ice-free summers for thousands of years. Bears in the high Arctic archipelago, however, contend with ice packs so thick that it's often impossible for them to hunt seals. In the southern reaches of the bear's range, warming can be catastrophic, but higher north, an increase in open water could potentially make hunting easier. Due to ice breakups, there is also more interaction between polar bears and snow geese, which polar bears cannot live on, but can certainly snack on. So other animal populations may be impacted if some polar bears begin to starve. There is also an argument to be made about hunting restrictions on polar bears and indigenous people's livelihoods. I mention this because while we can cite all of the numbers we want, sometimes it's useful to get more information from people who interact with polar bears every day. Terry Odla, the president of the Inuit Tapiri Kanatami, Canada's national Inuit organization, says that when it comes to really understanding how healthy the polar bear population is, it makes no sense to pit the feelings and hunches of far-flung conservationists against the direct observations of local people who deal with the bears all the time. When it comes to hunting specifically, some people believe it may be necessary to limit the increasing bears. Overall, as this article states, it's difficult to pinpoint exactly how bears are doing. There are more of them than there were 50 years ago, but there might not be for long. There are more sick and skinny bears showing up in certain areas. Not to mention, there are fewer cubs showing up in other areas. Polar bears are currently considered vulnerable worldwide, and melting glaciers are likely to have a negative impact on more southern residing polar bears and benefit more northern residing polar bears. Polar bear increase in certain areas may lead to competition for food or more contact with humans, which could be dangerous. I think this article sums up the problem with all of this polar bear stuff pretty well. According to the most authoritative scientific assessment, the polar bear does not face imminent extinction, and the widespread belief that it does now stands in the way of more nuanced communication about the dramatic effects of climate change in the Arctic. Leanne Clare, Senior Manager of Communications at the WWF's Arctic Program, explained this to me in Finland last week. When the symbol gets bigger than the region itself, and people don't realize that the polar bear is just one piece of a whole diverse web of life in the Arctic, then it can become almost a barrier, she told me. This is exactly why I chose to go over glaciers before polar bears. It's clear that glaciers, especially in the Arctic, are melting. But when we oversimplify this and therefore assume that polar bears are decreasing at the same rate that glaciers are melting, it becomes an issue for activists and scientists trying to raise public understanding of climate issues. Because when you think about it, how many people do you think there are that believe polar bear decline is the biggest indicator of climate change? how many people have condemned climate activism altogether because they investigated the polar bear fact themselves. I don't want to blame anyone who believed these things. It's hard not to when it's everywhere on social media, in news articles, and on protest signs. And perhaps the sources I found have undermined the polar bear decrease. I just can't know, because it's one of those issues that has too many nuances to fully explore for the average person. My point here is this: a little misinformation on one side goes a long way when it comes to reaffirming the opinion of the opposing side. Just keep this in the back of your mind. In conclusion, glaciers are melting and polar bears are maintaining themselves for now. As I said before, these aren't fragile creatures we're talking about. The Truth About Polar Bears article even mentions a study that shows polar bears could be 500,000 years older than previously thought, which means they would have adapted through many warm periods. Polar bears can most likely survive at least some natural variation of the Earth. Glaciers, less so. That brings up another question though. Is global warming just a natural cycle? Are we just moving from a cold cycle to a warm cycle? If that's the case, then polar bears may only need to adapt, and by that logic, humans will simply need to adapt. Our planet has been slowly warming since last emerging from the Little Ice Age of the 17th century, often associated with the Maunder Minimum. Before that came the medieval warm period, in which temperatures were about the same as they are today. Before I even begin to dissect this, I want to make it clear what the Little Ice Age and Maunder Minimum and all these other terms are referring to. The Little Ice Age is a period that lasted roughly, emphasis roughly, from the 14th century to the 19th century. This period consisted of lower than average temperatures, and it's believed to have been 0.6 degrees Celsius cooler in the northern hemisphere. One largely cited phenomenon when referring to this period is the Thames River in the UK freezing over. The medieval warm period was an expanse of warmer weather believed to have lasted from 900 CE to 1300 CE, so before the Little Ice Age. While it is uncertain how high temperatures were at this time, one analysis believes it to have been 1 to 2 Celsius warmer than early 20th century temperatures. The Maunder Minimum and the Dalton Minimum, the latter wasn't mentioned in the opening phrase, but it's still important, are referring to periods in which changing sun activity correlates with the coldest periods in the Little Ice Age, which is something I will explain in a minute. Lastly, one thing I need to mention is temperature fluctuations from both the medieval warm period and the Little Ice Age are almost entirely based on proxy evidence from physical material affected by the sun, i.e. ice cores, tree rings, coral, etc. Proxy evidence tends to be the main source of any climate data where there are either no records or unreliable records, as in the distant past. I will use this phrase a few times, so I wanted to clear it up. Anyways, the main argument specifically dealing with the Little Ice Age is that the Earth is currently coming out of the Little Ice Age, and that's why there has been a general warming trend for over a century. Part of this idea is also that this proves the Earth goes through prolonged shifts in temperature without human interference. Obviously, humans weren't releasing significant carbon emissions until the Industrial Revolution, so they could not have caused the medieval warm period nor the cold period that ensued. So why did the Little Ice Age happen? Would it make sense that we're just coming out of an unnaturally cold period? Remember how I emphasized that the Little Ice Age went roughly from the 14th century to the 19th century? Well, I pointed it out for a reason. The time frame for what constitutes the Little Ice Age is debated. It is widely agreed upon that there was a cool period. However, some will say it started in the 13th century and others will claim it started in the 16th century. The ending time is also disagreed upon. Not to mention, there are believed to have been significant fluctuations in temperature within the Little Ice Age, as stated here. There were two phases of the Little Ice Age, the first beginning around 1290 and continuing until the late 1400s. There was a slightly warmer period in the 1500s, after which the climate deteriorated substantially, with the coldest period between 1645 and 1715. Now, this definitely isn't saying the Little Ice Age isn't real. There's plenty of proxy evidence, art, and I'm assuming there are also written records about events such as the Thames River freezing over. However, calling it a very prolonged period of significantly colder temperatures may not be the most accurate way to describe it. Speaking of this, there is actually evidence showing why the temperature may have varied. One study done on the causation of the Little Ice Age cites abrupt kill dates for plants that would insinuate a sudden event causing cooling. Here we present precisely dated records of ice cap growth from Arctic Canada and Iceland showing the LIA summer cold and ice growth began abruptly between 1275 and 1300 AD, followed by a substantial intensification from 1430 to 1455 AD. Intervals of sudden ice growth coincide with two of the most volcanically perturbed half-centuries of the past millennium. Basically what this study is saying is that the Little Ice Age could have been caused by multiple volcanic eruptions. Another study that modeled volcanic eruptions in the later part of the Little Ice Age found that it ended because of recovery from volcanic eruption, as in less volcanically active periods. To explain how volcanoes could cause cooling, the idea is that aerosols, which are basically particles or debris, in this case from volcanoes, released from volcanic eruptions go into the atmosphere after an eruption and block sunlight, causing cooling. The biggest volcanic eruption ever recorded, Mount Tabora, made 1816, the year without a summer. Worldwide, temperatures were much colder due to the sun being blocked by aerosols. Heavy snow fell in northern New England on June 7th through 8th, with 18 to 20-inch high drifts. In Philadelphia, the ice was so bad, every green herb was killed and vegetables of every description very much injured. Frozen birds dropped dead in the streets of Montreal, and lambs died from exposure in Vermont. So no, volcanic activity causing cooling is not just speculation. Anyways, the first study asserts that volcanic eruptions most likely caused temporary cooling, and these initial temperature changes may have impacted other aspects of the climate, such as the efficiency of ocean currents bringing warm water to Europe. I feel now is the right time to point out why I am mainly saying Europe when referring to the Little Ice Age, or only the Northern Hemisphere. This is because the Little Ice Age is only well documented to have happened in the Northern Hemisphere. This is actually mentioned in the editorial against anthropogenic global warming. Cooling is known to have happened in the Northern Hemisphere, and it is most well recorded in Europe. This may not seem important, but because climate change debates often involve the argument that the global average temperature is getting warmer, I feel it's important to note that temperatures in the Southern Hemisphere may not have gone down at all. There is some evidence to show the Little Ice Age being a global event, but there isn't nearly as much as there is for the Northern Hemisphere. If we are just coming out of the Little Ice Age, it would certainly be true that at least those of us in the Northern Hemisphere are coming out of it. However, the overall disagreement about the starting and ending points of the Little Ice Age, the potential it could have only happened in the Northern Hemisphere, and the possibility that volcanic activity played a part in starting it, all leave too many uncertainties to conclude the Earth is just coming out of the Little Ice Age. There was one last thing to mention about the Little Ice Age, though. It's a theory I have neglected to mention on why it happened: sunspot activity.
Sign my petition, damn it.
Okay, I guess that sounds pretty good. What the?
Would you please sign my petition? Hi there, would you like to sign my petition?
No way, you freaking
climate denier.